Today we are going to study some prerequisites for trigonometry. First we'll see some common Greek alphabets that we use for angles. First being theta. Then next alpha, beta, gamma, delta and phi. These are some commonly used Greek alphabets. Now we'll deal with angles. Zero degree, 90 degree, 180 and 360 degree. 90 degree is somewhat like this and is also called a right angle. 180 degree angle in a straight line is 180 degree. That is why it's also called straight angle. An angle in one complete rotation gives 360 degree. That is why it's called complete angle or full angle. Any angle between 0 and 90, let us denote by theta. Let us denote any angle between 90 and 180 as say alpha, and any angle between 180 and 360 degree by phi. So any angle between 0 and 90, say 0.1 degree or 39 degree, 89 degree, all these angles are called acute angles. Please note that 90 degree is not included in acute angle. Theta starts right after 0 degree and completes just before 90 degree. 90 degree is called right angle, it's not included. Alpha, any angle between 90 and 180 degree is called obtuse angle. And any angle between 180 and 360 is called reflex angle. Okay. If sum of angles is 90 degree, then angles are called complementary angles. If sum of angles is 180 degree, then angles are called supplementary angles. Okay, let's now see some properties of angles. These are called vertically opposite angles. These are two parallel lines. To denote two parallel lines, we give arrowhead like this. And say this is a transversal line These angles are called corresponding angles. Again, parallel lines, another transversal line. These angles are called alternate angles. Vertically opposite angles corresponding angles and alternate angles are equal. Then we have, so again, two parallel lines. These angles on the same side are called co-interior angles. And these angles that forms a straight line, these two angles together, these angles are called as linear pair. So, co-interior angles and linear pair of angles are supplementary. When we add these two, or if we add these two, they form 180 degree. That is why these angles are called supplementary. Okay. After angles, we'll see different types of triangles. Triangles are classified on two types. So, either they are classified on the basis of sides, and second is classification on the basis of angles. Angles in a triangle is supplementary. That is, if we add all three angles in a triangle, they form a 180 degree. So, on the basis of side, first type of triangle is equilateral triangle. In equilateral triangle, all three sides are equal. We also know that equal sides opposite to them, the angles contained are also equal. So over here, all three angles are equal too. So let's name this triangle as triangle ABC. So angle A equals to angle B equals to angle C, and we know that angles in a triangle is supplementary. So angle A plus angle B plus angle C equals to 180 degree, which implies angle A plus angle B is equals to angle A, and angle C is also equals to angle A, equals to 180 degree, which implies 3 angle A equals to 180 degree, which implies angle A equals to 60 degree, which means that each angle in an equilateral triangle is equal to 60 degree. Second is isosceles triangle. In isosceles triangles, two pair of sides are equal. So opposite to them, the angles are also equal. So over here, exactly two sides are equal. And here angle, say ABC. So angle B will be equals to angle C. And third type of triangle is scalene triangle. Where all three sides are unequal to each other. Next is the classification on the basis of angles. First one is the acute angle triangle, in which all three angles are acute. So angle A, angle B and angle C all will lie between 0 degree and 90 degree. Please note that they may not be equal. Say this is 30, this is 60 and this is 40, this is 60 and this is 80. So they sum up to be 180, but all three are acute angles. Second is the right angle triangle. In right angle triangle, one of the angle is equals to 90 degree. So angle B equals to 90 degree. And we know that sum of angles in a triangle is supplementary. So angle A plus angle B plus angle C is 180 degree, which implies angle A plus angle C equals to 180 degree. Angle B is 90 because that side as subtraction, minus 90. So angle A plus angle C is 90, which means if there is a right angle triangle, excluding the right angle triangle, the other two angles are complementary in nature. They sum up to be 90 degree. And the third type of triangle on the basis of angles is the obtuse angle triangle. Over here, one of the angle is obtuse. Say angle A over here is obtuse. So both these angles B and C must be acute, because if one of them is between 90 and 180, if another also is obtuse, they will sum up to be more than 180. That is why angle B and angle C should be acute over here. And angle A plus angle B plus angle C, this should sum up to be 180 degree. This holds for all triangles. And the last property important as prerequisites for trigonometry is Pythagoras theorem. Pythagoras theorem can be applied only in right angled triangles. This is 90 degree. Opposite to 90 degree is the longest side called the hypotenuse. Side between 90 degree and the base angle is called the base. If this base angle is over here, theta, then this will become the base. It depends upon the base angle, where the base angle is. We consider the base and the perpendicular. And opposite to this theta is the perpendicular. So what Pythagoras theorem says is that, say let's denote hypotenuse with h, perpendicular with p, and base with p. So according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square. Let's take one more example to clarify this, what base, perpendicular and hypotenuse is. Say this is 90 degree and say this is theta. So opposite to the 90 degree is the longest side called the hypotenuse. Between 90 degree and theta is the base, and opposite to theta is called the perpendicular. So we complete the prerequisites for trigonometry. We'll begin with trigonometry in the next class.